So this is a very nice follow-up to the previous podcast on farmers' perspective on carbon markets, focused on sequestering additional carbon into soils. And we made some good points, and this actually is an article from New York Times, so we don't always have to read peer-reviewed literature to learn things. Somini Sengupta, who wrote this article, usually writes very nice pieces. I have talked to her once or twice, and this is about, again, carbon sequestration and a slightly different approach. Can dirt clean the climate? An Australian startup is hoping fungi can pull carbon dioxide from the air and stash it underground. It's one of several ventures trying to deploy the superpowers of soil to slow global warming. As I said in the previous podcast, I love soil carbon as a solution, plus just also the co-benefits, I would say more direct benefits on soil nutrients, soil moisture, drought resilience, and crop yields, farmers' incomes, and so on. So this is actually a video. Let's see if I can play it here. Why doesn't it play? Ta-da-ta-da. There is a way to play this, I am sure. Let me see. It is, yeah, there we go. So can you see it? Can I put it on? Yeah, there we go. So it's just the New York Times loves to use little videos because they play when you click on the link. Usually they don't let you download it, so somehow here it is allowed me to download it. But basically you can see a farm machine, a plow, going through and preparing the land for sowing, and doesn't tell us. Oh, did I double do it? Yeah. Doesn't tell us much, but just a nice prop to discuss the topic. Across 100,000 acres in the vast agricultural heartland of Australia, an unusual approach is taking root to slow down the wrecking ball of climate change. Australia has been very sensitive to it because they directly get hit by El Nino and La Nina, plus they have large part in the middle is desert. Only in the north you have very heavy rain, Darwin and so on. It's all in the tropics, and then on the coasts they have some rain and so on. So our population is small, and yet they have to worry about agriculture a lot. So an unusual approach is taking root to slow down the wrecking ball of climate change. Farmers are trying to tap the superpowers of tiny subterranean tendrils of fungus to pull carbon dioxide out of the air and stash it underground. It's part of a big bet that entrepreneurs and investors around the world are making on whether dirt can clean up climate pollution. They're using a variety of technologies on farmland, not just to grow food, but to also eat the excess carbon dioxide produced by more than a century of fossil fuel burning and intensive agriculture. So agriculture and fossil fuels still continue to emit a lot of greenhouse gases. Why fungus? Because fungi act as nature's carbon traders. As they sow their crops, farmers are adding pulverized dust of fungal spores. The fungus latches onto the crop roots, takes carbon that is absorbed by the plants from the air and locks it away in subterranean storage in a form that may keep it underground for much longer than the natural carbon cycle, where the carbon that is sequestered by the plants is then feeding the microbial life and so on, which is part of the natural cycle, but now we need to increase the residence time so fungi can help. The fungal venture, the handiwork of an Australian company called Loam Bio, loam is a kind of soil, as you know, is among several startups to have mobilized hundreds of millions of dollars in investments in efforts to use soil to remove carbon dioxide from the atmosphere. Like Loam Bio, companies like Andes and Groundworks BioAg are also experimenting with microbes. We talked about soil microbiome engineering in one of the previous podcasts. Lithos and Mati offer farmers crushed volcanic rocks that absorb carbon to sprinkle on their fields. This is called accelerated weathering. Silicate carbon is milling leftover concrete into a fine powder, while several companies are scorching crop waste into charcoal. So biochar is one thing, and charcoal is basically like a biofuel. You have to be sure about emissions and so on, or you can bury them in the ground. It's also ideas exist about growing trees and burying them deep in the ground or deep in the ocean. The appeal of the Australian startup is that it doesn't demand too much of farmers. Pretty simple is how a fifth generation Australian farmer named Stuart MacDonald described his experience as he sowed a dusting of fungal spores with his wheat and canola seeds on his farm near Canowindra this year. It's not asking us to change too much. It's not a big capital outlay. So here's Stuart MacDonald, a fifth generation farmer near Canowindra searched for freshly planted seeds coated with loam's fungal treatment. So he's on the ground doing his field work there. It's still early days for most of these ventures, and exactly how much excess carbon they can remove and how long they can keep it underground remains contested, but their side benefits may be equally profound. They're all aimed at restoring the health of the soils that have been degraded by decades of intensive agriculture by restoring microbes and minerals that they once contained. The carbon removal potential of soils is huge. Soils hold 3 times more carbon than the atmosphere, and they can potentially absorb more than 5 gigatons of carbon dioxide per year, or 1/7 of all the carbon dioxide that human activity injects into the atmosphere, which is in the range of 40 gigatons or so. According to Intergovernmental Panel of Climate Change, these numbers hold up. That makes them the world's second largest carbon store after the oceans. We don't even think about it, but that's pretty significant. I think soils will play a key role, said Rob Jackson, a climate scientist at Stanford University, though he was skeptical about whether the promise of fungal additives in field tests can have a statistically significant effect on working farms. So there are farmers and investors and entrepreneurs trying it on the field, and there is an academician sitting and saying he's skeptical. So we have to just try it, right? If there are no negative effects, unintended consequences, then it's worth trying. We would need to touch billions of acres to make a real difference, and we can. Why not? Not to mention agriculture itself creates a climate problem, accounting for 1/4 of the world's greenhouse gas emissions, but we all eat, so we cannot blame agriculture. We just need to reduce emissions from agriculture. A researcher inspected fungal specimens of one of Loam Laboratories in Orange, New South Wales, and this is a soil sample from farmers being air dried in preparation for carbon analysis at the Loam Laboratories. So they are actually measuring what's happening to the carbon. Loam Bio's fungal talcum has been spread across 100,000 acres in Australia this year, with 250,000 acres expected to come online next year. A half-dozen farmers in the United States are trying the product on their soy fields. Field tests are underway in Canada and Brazil. Data, metrics, reporting, verification. That's what we need, and not skepticism. Loam Bio has attracted $100 million in investment. Maybe it's US or Australian, you have to see. So far, and making it among the most well-funded of the many startups looking for ways to store more carbon in the dirt. Critics are concerned that the new technologies treat the symptom and not the cause of climate change. They can't be used as an excuse to continue burning fossil fuels. Of course, that's obvious, Jackson. Come on. Loam Bio's co-founder and the 6th generation farmer, Tegan Knox, agreed. This is just one of the things that can buy us time. Of course. What's the big deal? In the sense that we are not anywhere close to slowing down burning fossil fuels, let alone stopping it. In the meantime, you need to do everything we can that can help the soils, help crop yields, and help take down CO2. That's it, right? Why Australia? Not all farmers are doing this out of altruism. More carbon means better soil health and better yields. We talked about this before, but in Australia, farmers have another motive. They hope to reap a harvest of government issued credits if they can demonstrate they have stored carbon underground. This is what we talked about before. This is not the first time that farmers in the area have tried to cash in on soil carbon. It's something used to be called clean development mechanism, where you show that you are storing additional carbon. You're doing farming and you may be doing holistic approaches of increasing soil carbon, but this is doing more than that by active ingredients like fungal seeds. Once Mr. McDonald's 52 trucked in solid waste from Sydney's sewage to fertilize his fields and measured a small uptick in soil carbon, but he has no idea how long it lasted. Some farmers planted trees on a portion of their land and soil carbon increased for a few years, then flattened out. So that's agroforestry. These are virtuous cycles, but how do you keep on adding more and more carbon? That's not that easy. Critics said carbon credits were awarded not for substantial changes but for seasonal fluctuations in weather. In unusually wet years, carbon accrued in the soil only to dissipate in dry years. That's natural cycle. One study warned that the number of carbon credits issued for farming projects was inflated. And about dry years losing carbon, agroforestry is something that will enhance soil moisture persistence, reduce evaporation, and increase soil carbon. Soil carbon also increases soil water holding capacity. So there are ways to try to reduce water vapor or soil moisture loss in dry years. Accounting for carbon in soils is complicated by the fact that it comes in different forms. Most soil carbon is in the form of highly volatile organic matter. On farmland, that would be plant residue or manure. It can return to the atmosphere in a matter of years, or a drought or fire can burn it up even faster, releasing carbon dioxide back into the air. Yes, we cannot avoid these. This is Steve Nicholson and his grandson Hamish Nicholson on a freshly sown field on the family farm, and a nice moon in the background there. And they are here looking at a seed coated with loam fungal treatment. That's in his hand in there. And to read more, but there are more stable types of soil carbon, including one that attaches itself to minerals in the dirt and remains there for a century or more. Loam Bio says that its fungal spores can help build the more stable soil carbon. They measure it for their farmer customers using 1 meter deep soil cores. Quantification, monitoring. Fungi do the vital work underground. They take the carbon dioxide that plants pull from the air during photosynthesis, stash it underground, as we said before, and give back nutrients that plants need. So there is a symbiotic relation. To Alan Richardson, a soil biologist at the Commonwealth Scientific and Industrial Research Organization, CSIRO, of the government agency of Australia, the concept of using fungi to store carbon underground makes sense, but it would work only if farmers applied fungi year after year, allowing soil to build carbon over many years. So the carbon storage has to go deeper and deeper and increase the residence time of the carbon. The fundamental principle behind it is sound, but whether it translates into practice, we don't know, but we have nothing to lose but try. Still, Steve Nicholson, a farmer near the town of Forbes, is so bullish on the prospect that he signed a 25-year contract with loam. It's a gamble, he said, but it's a very, very good gamble, and I agree with Steve Nicholson. Loam technicians measured his baseline soil carbon in February. At the peak of hot, dry season, they will be back to find out whether his soil carbon has increased the following February, and to determine how much of it is in the more stable forms of carbon. Miss Knock, the co-founder of Loam Bio, tells her customers they can expect to store 1 to 2 tons of stable carbon in every hectare, or 2.4 acres. Australia's government-run carbon credit agency will have to verify how much carbon he has added before issuing any credits. Mr. Nicholson hopes to cash in by next July. His earnings will depend on Australia's carbon price at that time. He's eyeing more than 100 Australian dollars, or about $65 per hectare. So co-benefits are much more important than just this little cash. The world's ravaged soil, to look at a bit more on how we are hammering the soil carbon loss or accelerating them. Controlled burning on a farm near Parks. Farmers in Parkes. Farmers in the area have used burning for generations, believing it helps rejuvenate soil by clearing weed seeds and fungal pathogens. Agriculture is increasingly bedeviled by its own environmental toll. The quest to feed the world has ravaged the land while emitting vast amounts of greenhouse gases. Clearing forests, plowing the ground, applying chemical fertilizers, this activity has altered most of the earth. The changes are evident on Mr. MacDonald's farm as well. His ancestors, settlers from England, began tilling the ground in Australia in 1888. They grew acres of wheat foreign to this continent at that time. They raised cattle and sheep, also foreign, coming in from outside. Over the decades, Australia became an agricultural powerhouse. Also over the decades, as farming intensified, layers of topsoil wore away, soil carbon levels dropped, the dirt degraded. Erosion is something everyone accepted, Mr. MacDonald said, until they no longer could. About 20 years ago, Mr. MacDonald, like many of his neighbors, stopped tilling. After each harvest, he let the crop stubble decompose naturally. It helped to hold moisture in the soil and slow down erosion, but did little to build soil carbon, according to scientific studies. So Stuart MacDonald here is looking at a handful of dirt from a field freshly sown with canola seeds coated with Loam's fungal treatment. So he's very curious. He's always tracking his field to see what's happening. Neil Westcott, a farmer and a mayor of Parks, is sitting in his office, and he has vested interest as well. Now climate change poses a new risk. A drier and hotter future threatens to release much more carbon from the soil, according to scientific models. Australia's climate targets mean agriculture must change. Its government has set out to reduce its greenhouse gas emissions by 43% by 2030 compared to the 1990 levels. Baseline matters here because by 1990 you were already very high, so you are reducing only with reference to a high baseline, but everybody is doing this part of the game. Agriculture represents around 14% of those emissions. Neil Westcott, also a wheat and canola farmer and the mayor of a small farming town called Parks, has his eye on the future. He wants to reduce his farmers' climate effects soon. He reckons he may have to if the government requires climate pollution cuts or customers abroad want low carbon crops. Smart guy, right? So look at him. He looks smart. Mr. Westcott, 64, has stopped raising sheep, which produce methane, a potent greenhouse gas, and he has sown about a quarter of his 6,000 acres with fungus powder. He hopes there will be carbon credits, but he isn't planning to sell those yet. He wants to hold on to them for when he may have to neutralize his own farmers' carbon emissions. So he wants to trade carbon emissions for carbon credits. I have my own carbon footprint I need to cover, he said. I'm sick of just talking about it. I have got to do something. Lovely article by Somini Sengupta, and I'm sure New York Times doesn't mind that I use their article for podcast and serve it to the public. Copyrights issues, etc., are something I have to worry about, but I'm not making any money out of this yet. Well, not yet, and I doubt I will ever, but this is useful for humanity, so I'm sure New York Times doesn't mind. See you in the next topic, which is about how to solve the food puzzle, which is about how to feed people without making climate change worse, which follows nicely on these topics as well. Okay, see you.